Hi guys, here are the notes for 7.2. We're going to be working with arithmetic sequences and series. So we'll be able to write and use arithmetic sequences and series. Okay, let's talk about what is an arithmetic sequence. Well, that's basically the difference between consecutive terms and its constant. We call this the common difference. So basically going from one term to the next, it should be constant and you're either adding or subtracting the same number. So here we're going to go ahead and tell whether the sequence is arithmetic. So this is our example 1. Let's do part A together here. So what we're going to determine is we're going to figure out to go from -4 to 1, what do we add or subtract? Well, to go to -4 to +1, we add 5. Okay, let's see about 1 to 6. Well, to go from 1 to 6, we also add 5. Okay, 6 to 11, we add 5. And then 11 to 16, we also add 5. So here, it seems that we do have something that's consistent. And so that means this would be an arithmetic sequence. I'm going to put yes. So let's also talk about the common difference, okay? So the common difference in this case is going to be +5 because we added 5 to each of our terms to get to the next one. Now, I know I didn't ask us to do that here, but I do want to explain what that was so you guys can reference. So I definitely make sure to write this down in your notes. So the common difference here was 5. Okay, go ahead, try part B on your own. So pause the video and go ahead and try part B. Okay, let's go ahead and do this one together. So to 3 to 5, it looks like we had to add 2. 5 to 9, we had to add 4. 9 to 15, we had to add 6. And I really don't have to do the next one because notice here that when I add a value, it is not constant. So because when I go from one term to the next and it's not constant, that means this is not an arithmetic sequence. So I just put no. That's my final answer here. Okay, so let's talk about the rule for an arithmetic sequence. So let's look at that. So the rule for an arithmetic sequence, it says the nth term of an arithmetic sequence with the first term a sub 1. So remember we kind of talked about this in our last video. So this is going to represent our first term, and then it says common difference D. So we talked a little bit about common difference in the last example. We're going to reference that as D. And so we do have a little formula. So definitely make sure, like if you're writing this on a separate sheet of paper, you write this down, or if you are using the blank notes, you highlight, you star, do whatever you need to do so you remember this, okay? So this is saying a sub n, where n is any term, okay, equals a sub 1, which is our first term, plus n minus 1 times d, which is our common difference. So here they have given us an example. It says the nth term of an arithmetic sequence with the first term of 2 and a common difference of 3. So what they did is they plugged 2 and 3 into this formula. So they plugged 2 into a sub 1, and then for d, they plugged 3 into here. Now, notice the next step, and I'm going to highlight it in blue here. It's a little bit different, or a sub n equals -1 plus 3n. Now, you might be wondering, well, how did they get this? Well, what they did was they simplified, meaning they took the 3 and multiplied to the -1 and the n. So I'm going to go ahead and do this math right now so you can see how we got -1 plus 3n. So when we have this, we have a sub n equals 2 plus, and then 3n minus 3. So when they simplified, they did 2 minus 3 to give us -1, and then they have the plus 3n. we really want to write this in simplified form. Okay, so if you can, make sure to write this in simplified form. So don't leave it like this unless they tell you to do so. Just put it into simplified form. Okay, now let's go ahead and go to example 2. So that's what we're going to exactly be doing here. They're going to be giving us basically our a sub 1, our common difference, and then we have to use the rule to find our arithmetic sequence. Okay, we're going to do example 2a. So it says write a rule for the nth term of the sequence. Then we're going to find a sub 15. Okay, so the first thing we need to identify, or let me go ahead and do this. I'm going to write out the rule. I would always say doing that because it helps you remember what it is. So remember, it's a sub n equals a sub 1 plus n minus 1 times d. Okay, so our a sub 1 is always the first term of our sequence. So notice here that our first term of our sequence is 4. Now our d is going to be that common difference. In order to figure this out, we need to determine, okay, how can we go in order to get this sequence? Well, going to 4 to 9, that shows that we added 5. And then 9 to 14, I added 5. And then 14 to 19, I also added 5. So it looks like my common difference is going to be a positive 5. So now I plug that into my formula. So I have a sub n equals 4 plus n times 1, or n minus 1, excuse me, now times 5. Now I'm going to go ahead and simplify this rule. So that means I'm going to go ahead and I'm going to distribute the 5 to the negative 1 and to the d, or to the n. So I have a sub n equals 4 plus 5n minus 5. And let me go ahead and simplify that. So I get a sub n equals 5n minus 1. So there's part 1 of my problem. Okay. Now before I move on to the a sub 15, how to find that, notice this here. When I have my a sub n equals 5n minus 1, right? Know that this is actually similar to a linear function. With our linear function, we have a y-intercept and we have our slope. Similar here, we have kind of like the y-intercept, and 5 is going to be considered our slope. Remember, with linear functions, slope either goes up or goes down at a constant rate. So you can always think of, well, arithmetic, that's very similar to the idea of linear functions because our rule is going to be linear. So it's either going up or down at a constant rate. So I just wanted to throw that in there so you guys kind of had a connection to how these arithmetic sequences kind of deal with some of the other functions we've dealt with in math. Okay, now our last thing that we're going to do is determine a sub 15. So what's going to happen is I'm going to plug 15 in for n into our rules. I'm going to have 5 times 15 and then subtract 1. So that's why it's kind of maybe easier just to put it into this linear equation because it's easier to figure out our answer here. So our a sub 15, when we basically simplify this, 5 times 15 gives us 75, minus 1 gives us 74. So that will be our final answer for the second part. Okay, what I would like you guys to go ahead and do is pause the video and try part B here. So you're going to do the same thing. You're writing the rule and then find a sub 15. So go ahead and pause the video to do that. Okay, let's go ahead and go over this. If you got stuck, let's see if we can get you unstuck here. So remember our rule here for arithmetic sequence. We got a sub n equals a sub 1 plus n minus 1 times d. Okay, so we need to determine our a sub 1. Remember, that's always the first term of the sequence. In this case, it's going to be 60. Now we need to determine the common difference, or the d value. So if we go from 60 to 52, no, this is actually, we're decreasing. We're decreasing by 8, so I'm subtracting 8. Then 52 to 44, I'm also subtracting or decreasing. And then 44 to 36, I decrease or subtract 8. So that means actually my common difference is minus 8. You do have to include that negative sign because we are decreasing, okay? So now I'm going to plug these two into my formula here. So I have my a sub n equals 60 plus, and then I have n minus 1 times negative 8. Okay, I'm going to go ahead and put this in parentheses as well, so you know that's not minus 8, but timesing a negative 8. Now I'm going to go ahead and distribute my negative 8 to the negative 1 and n. So I have a sub n equals 60 minus 8n plus 8. So my rule here is going to be a sub n equals negative 8n plus 68. Okay, and notice that because my d value is decreasing, if we thought of this as like a linear function, it's basically a downward slope. So it's decreasing going downwards. Now, if you had trouble trying to get this and you didn't go for finding the a sub 15, go ahead and pause the video and find a sub 15. Okay, let's go ahead and go over this together. Okay, so I have a sub 15. I plug that 15 and 4n into our rule. So I have negative 8 times 15 plus 68. And really, you can just use your calculator to do that. So my 15th term, that's what a sub 15 represents, my 15th term is going to be negative 52. Okay, let's go ahead and do example number 3. So example 3 says one term of the arithmetic sequence is a sub 19 equals 48, and the common difference is d equals 3. We need to write a rule for the nth term. So kind of just going back to our formula, I'm always going to reference that. So we have a sub 1 equals a sub n equals a sub 1 plus n minus 1 times d. Now in this case, we do not have our first term, but we do have an a sub n. In this case, we have a sub 19, and that a sub 19 is 48. So actually, I'm going to plug 48 into my a sub n here. So I have 48 equals a sub 1. So I'm really going to try to find what my first term is. Now, I have n. Remember, my a sub n, we said, right, was a sub 9, or 19. So that means my n value is going to be 19. So I have 19 minus 1 times my d, which in this case is 3. So what I have to do is figure out what is my first term, and then once I calculate that, I can replug it back into my formula to find the rule along with the common difference. Okay, so I do 19 minus 1, that gives me 18. So I have 48 equals a sub 1 plus 18 times 3. That's going to give me, so I have 48 plus a sub 1 plus and go ahead, you can do like 18 times 3 in your calculator if you need to. That's going to give us 54. And basically to get a sub 1 all by itself, remember you need to subtract 54 from both sides. So I'm going to subtract 54. So meaning that my a sub 1 is going to be negative 6. Okay, so now I'm going to replug that into my rule, into the formula. And I'm going to plug in my common difference. So remember, the common difference is 3. So I have my a sub n equals negative 6 plus n minus 1 times 3. And I'm going to go ahead and distribute that 3 to the 1 and n. So I get negative 6 plus 3n minus 3. So my rule here is going to be a sub n equals 3n minus 9. There we go. And that'll be my final answer there. Okay, let's go ahead and go to example 4. So here it says two terms of an arithmetic sequence are a sub 8 equals 21 and a sub 27 equals 97. We need to find a rule for the nth term. Now notice here they have not given you the first term, a sub 1, and they didn't give you the common difference. So what we're actually going to do is plug both of these into the formula, and then we're going to do a systems of equations basically to find our common difference, and then we'll figure out our a sub 1, okay? Here's my formula, which I always have. Okay, so first, let's go ahead and plug this into here. So my a sub 1 is going to be 27 equals a sub 1 plus my n value is going to be 8. So I have 8 minus 1 times d. And I do the same thing here. So my a sub n is going to be 97 equals a sub 1 plus 27, because that should be my n value, minus 1 times d. Okay, now I simplify. So I have 21 equals a sub 1 plus 7d, because all I did was 8 minus 1. And then I do the same thing here, 97 equals a sub 1 plus 26d. Now what I'm going to do here is basically subtract, because that will allow me to eliminate my a sub 1s. Okay, so I'm going to subtract. So when I do this, I do 21 minus 97. That gives me negative 76. My a sub 1s cancel. And don't forget this one, 7d minus 26d, and that gives me negative 19d. So be careful with that. What I would suggest is probably changing that negative into the positive and then changing each of these signs. That'll allow you to not forget to subtract your d value here. So now to solve for d, I divide both sides by negative 19. And that will give me a positive 4 for my d value. Now that I found my d, I'm going to go ahead and plug this back into my formula. And then I'm going to use either the a sub 8 or a sub 27 to plug back into my a sub n and the n to figure out my first term, a sub 1. Now, it doesn't matter which one you plug in, but what I would advise is plugging in the easier one. So that means I'm going to go ahead and use my a sub 8 equals 21, because I think that's going to be a ton easier to use. So that means I have 27 equals a sub 1 plus 8 minus 1 times 4. So going to calculate that, I have 27 equals a sub 1 plus 7 times 4. So that'll give me 28 when I do 7 times 4. So I have now 27 equals a sub 1 plus 28. I subtract the 28 to the other side. So that means I get a sub 1 is equal to negative, let's see. Whoops, I made a little mistake here. There should be a 1 there, first of all. And then down here, this should not be 27, it should be 21. That was my mistake, sorry guys. So go ahead, if you wrote 27, change those out to make it 21s to make this make more sense. There we go. Okay, now I subtract 28. That gives me negative 7 as my a sub 1. And then plugging it back in, I have my a sub n equals negative 7 plus n minus 1. And then times my d, which is 4. I distribute this, and I think you guys can figure out the math from here. I think you guys have been doing really good at that. So your final answer, you should get a sub n equals 4n minus 11 as your rule. Okay, we have one more example, and this is where we're going to be talking about series, the sum of series. So an arithmetic series is expression formed by adding the terms of an arithmetic sequence. Okay, the sum of a finite arithmetic series. So the sum of the first n terms of an arithmetic series is using this formula. So we have s sub n. S represents sum. N represents basically like the number of terms, okay, equals n times a sub 1. Remember, a sub 1 is your first term, plus a sub n, which is your last term, divided by 2, okay? So n represents the number of terms you're adding together. S sub n just represents your sum. Your a sub 1, as usual, represents your first term. Do this. There we go. So that's going to represent your first term there. And then your a sub n, that's going to represent basically your last term. Okay, so now we're going to go ahead and use this formula to do the next example. So it's going to be our example number 5. So what is the sum of the arithmetic series? Okay, So we have the sum of 3 plus 5i, where I equals 1, and we go all the way to the 20th term here. So using our formula, kind of going back to that, remember we have S sub n equals n times a sub 1 plus a sub n divided by 2. Okay, so we need to first determine our n value. That means the number of terms we're adding together. Know that since we're going from 1 to 20, we're actually adding up 20 terms, so our n value is going to be 20. Then our a sub 1, we actually have to calculate that. So in order to calculate that, we have to plug 1 into our rule here. So I'm going to put this off to the side. So a sub 1 is going to be 3 plus 5i, or 5 times 1. And that's going to equal 8. So our first term is 8. And then our a sub n, which is our last term, in this case is going to be 20. So a sub 20 is going to be our last term. So I have a sub 20 equals, and I'm still going to use that rule, 3 plus 5, and I multiply by 20. So that's going to be giving me 103. So using this information, I have my sum of the first 20 terms equals 20 times 8 plus 103 divided by 2. So when I do this, I get 20 times 103 plus 8, which gives me 111. So I have 20 times 111 divided by 2. Plug that into your calculator, and that means the sum of the first 20 terms of this arithmetic sequence here is going to be 1,110. And that would be our final answer there. Okay, make sure you work on the homework for this section. If you have any questions, make sure you contact me, and I will see you guys later. Bye.